Hello, good morning, dear organizers and the participants. Thank you so much for having me here in the fourth refresher course in the development studies, which is organized by UGC Human Resource Development Center, University of Calicut. And here, this is my topic. My topic is the introduction to geostatistics and spatial data modeling for development analysis. In this topic, I will discuss three important things. What is geostatistics? Second, how geostatistics play important role in the developmental studies. And the last is the geostatistics concepts, methods, and exercises. I'm Dr. Zubairul Islam, and down these are the links given. First is my email, second is WhatsApp number, and then what my website, and the last is the YouTube channel. In the YouTube channel you will find many videos related to geostatistics and spatial data modeling. Here these are my recent publication in the form of book, that is Geography of India, and another is India and World Geography. So let's begin. So the first is what is geostatistics. Here, if you see the word geostatistics, it's a combination of two words, geostatistics. And the statistics, as you know, is a broad field that involves collecting, analyzing, interpreting, and presenting data to make informed decisions. While geostatistics is a specialized branch of statistics that focuses on analyzing spatial or geospatial data. So when I say spatial data means if spatial data will have the coordinate information in the form of latitude and longitude. So it helps us for creating a map that shows how things change uh, or vary across a landscape. And it helps us to understand the pattern in the data and predict what might happen in place where we do not have the measurements. As you can understand that if you are doing any survey, I mean, you will choose maybe few areas that, okay, these are the values here at the red points. But what about the values where the points are not given? So with the help of geostatistics, we can predict and we can create the raster layer or continuous layer, because this is discrete information. The information is uh, at the points only, but in between the points, there is no information. For that very purpose, geostatistics plays a very important role. For an example, the weather stations may be in a district, maybe 5, 6, 7, 8. So, or at a state level, maybe 150 or 200, 250, whatever. So the records are at the stations. So with the help of those records, and using geostatistics, what you can do, you can fill the gaps and make the research based guesses that what temperature might be at different spots. So it helps us to understand the patterns and the uh, pattern and the spatial distribution. And we can, if we have more than one variable, then we can establish the relationships also. So the second point is how geostatistics plays an important role in the developmental studies. So developmental studies, all those studies which are related to the surface of the earth, where you have to collect the data on the surface of the earth. It may be related to any field of study, any field, from social science, from science, or geophysical sciences, etc. So in these fields, geostatistics plays an important role to understand or to provide the valuable insights into the spatial distribution and variability. So it will help the researchers very well, and ultimately you do your research to help the planners and policymakers. So uh, it will be very useful for the especially in the research fields. And now I will talk about what are the fields where you can use the geostatistical analysis. This one is for need assessment. If there is a region, it may be a micro region, meso or macro, small or uh, larger, or any large area. So if you have the data, then you can uh, calculate or you can analyze the need assessment. Infrastructure planning. For that, you should have the data for anything, for any work. You must have the data first of all. Then if you are having the roads data, the data related to the trees or buildings or communication towers or etc., then with the help of all these information, you can plan the infrastructure, that where infrastructure is less and where infrastructure is more required. Poverty mapping. Poverty mapping you can do with the help of data you have, and uh, such type of data will be very helpful to visualize the information that where the poverty is high and where poverty is low. Similarly, in the field of education, if you have the data that where school exists and at different levels, maybe primary, secondary, or at the college or university level. So with the help of that data, you can interpolate the information with the help of geostatistics. Health services. For instance, you are having the point data related to the COVID cases, and each point is having like how many cases are there, data related, maybe, I mean, how many cases the people die. So with the help of that information, you can make the maps, you can interpolate the information, or you can make the hot spots or cold spots. Agriculture uses, if you have some data here, just I mean, these are images, these are the images which are taken just to explain you, but this is a large region, I mean it's a country, but at a smaller level also of any part of the world, you can collect the data, and with the help of that data you can analyze the pattern or hotspot, or you can do some spatial relationship of the information related to agriculture. Natural resource management. Natural resources may be in the form of water, maybe in the form of soil characteristics, or it may be in the form of, I mean, the resources. There are different types of resources. If you are collecting the data, so that data you can use, I mean, that data you can use to analyze the natural resources, and you can study the spatial pattern and the hotspot. And even if you have the point data, with the help of that point data you can make the raster surfaces, or continuous information. Disaster risk assessment. There are different types of disaster. It may be a flood, it may be a landslide, it may be earthquake. So uh, you can make the areas where flood may be possible here based on the information, based on the data. Sometimes what happen, the Indian Meteorological Department can give the information to you that maybe after 2 3 days, 4 days, rainfall may be very high. How much rainfall will be there? So based on that information, how much water flow will be there, and what is the slope of the area, and you can predict that, okay, as many people, or this population may be affected due to the flood area, like that. The next is urban development and housing. Okay, this work may be related to some kind of, the officials who are interested to make a map to plan the area, or the plan the development for next 10 years. Then they can use the geostatistics for that very purpose also. Regional development policies, there are many guidelines, and there are many plans, programs, developed by the government. So based on those plans and programs, you can study any part of the earth to meet the objectives of the program or plans. So now the third part is, I will talk about the geostatistics. And in this part, you have to think, and you have to analyze yourself, that where you can use the data for your studies. I mean, it is not possible to cover each and everything in this lecture, but when you will be familiar, and when you will know, okay, this is the technique. So there are different types of data which you can use to study the area of your interest, and you can use the geostatistics in your studies. So here I will focus on the pattern analysis, the second, hotspot analysis, and the third is the modeling of spatial relationship. So first we will take the distribution pattern analysis. Okay, when you will write the distribution pattern analysis in Google Scholar, then within means less than a second, you will find how many results are there. You see, uh, I think 1.8 million. So spatial pattern, the pattern is a very favorite topic of the researchers, and these researchers are studying like distribution pattern analysis of green space in Medina using GIS, or there are maybe another like GIS based spatial pattern analysis. So the pattern analysis here, the pattern analysis. Okay, what I think is, I know my subject, in the geography or environment sciences, we choose a topic, we set the objectives. So what I think is, the research begins with the pattern. If any problem is there, for instance, the COVID cases. So the first objective I will think of is, what is the pattern? Okay, the pattern may be uh, dispersed, it may be the clustered. So if it is clustered, then another objective automatically. What is the reason why the problems are more clustered to this area? Why not to the, I mean, if it is clustered, means the more problems will be belonging to a specific area. So the first objective in the study will be the pattern analysis. What is the pattern? In your field also, if you are from, suppose, sociology, then any social problem, if you have collected the data, then first of all, you should know that what is the pattern of the problem. So this thing is very important, first thing. And the second is, and it's very easy to analyze the pattern. So let's see. Uh, Distribution pattern analysis. So there are different ways, but the most commonly used is the average nearest neighbor analysis. In short, this is known as ANN analysis. So what happens? There is a software, because if this is a simple statistics without spatial analysis, then you can do a lot of things with Excel also, and another statistical software packages. But when it is geostatistics, then you have to choose a software which is related to the GIS. So here the ArcGIS is the most common software which is used to study the spatial statistics. And this software you can collect from Google, and you can install in your laptop or desktop, and everything is available with the help of videos. You can install also easily. And maybe you may be interested in ArcGIS. If you are interested, if you want to know more about ArcGIS, and if you stuck at any point, then you can contact me too, that okay, where is the software, I mean, from where we can take the software and how we can install it. So uh, how it helps you to determine the distribution of the points, whether this is clustered, dispersed, or random. So in this one, what happens? The analysis calculates the average distance from each feature to its nearest neighbor and compares it to the expected average distance. So the result will show you whether it is dispersed or clustered, or it is maybe random. So generally what happens if the pattern is clustered? If pattern is clustered, then in most of the cases starts. Research starts. Why? Because there will be a reason of clustering. That reason you have to search, you have to find. And in this lecture, I mean, you can use the spatial relationship modeling. That also at the end I will cover within this topic here. So first of all, uh, uh, say that this is your first objective, that what is the pattern of the problem. So it will be more clear when I will explain you with the help of the software. I will explain you everything there. So uh, what you need for that, how it works, how to perform the average nearest neighbor analysis, and this is the name of the software. Wherever ArcGIS is there, I'm talking about a software. Okay. So first of all, you should have the data, and that data you have to load in your software. And maybe I mean, I'm thinking that you might be thinking that how we can install a software and how to begin. I mean, if you are interested, then you can do it. I'm sure my friend Dr. Monir said to me that the participants do not have the background of GIS. So that's why I designed this lecture uh, systematic, and I have I'm not going to very advanced level. Just I have to give you a kind of introduction or preview. Even I will go through the some practical exercises, and when you will begin, then step by step, slowly, you can go from beginning to the advanced level too. So uh, what you will do, you will load the data. The data should have the coordinates latitude and longitude. So there is a CSV file, or it may be KML file, or it may be a shape file. That format you can use to analyze this average nearest neighbor analysis. So what you will do is the data type may be a point, it may be a line, or it may be a polygon. So what is this? You can what you will do is you will take the tool, and the tool is average nearest neighbor tool. So for that, you will configure the tool. How you will configure, because the data you will be having in the software, when I will show you with the help of software, it will be clear to you. You will give the features, then you will give the output location, then you will give the conceptualization of a spatial relationship. Okay, it may be a fixed distance band, or it may be another also. Then you will choose the distance method. So in the distance method, it may be Euclidean distance, or it may be Manhattan type of distance. And then you will click the run, and it will work itself, and your result will be there. So here everything is clear, but here maybe Euclidean and Manhattan distance. I will talk when I will explain with the help of software. Or you can understand, you can have an idea that if suppose, let's make the here X and Y. So in the X and Y here, X and Y, if there are 2 points, one is this, another is this. So in Euclidean distance, what happens? The software calculates, this is what this distance, straight distance, okay? This is A, B, C. So it's a straight distance, AC. So you may be familiar with some mathematical formula, as you know, Pythagoras uh, equation here. So with the help of the distance of AB and BC, you can calculate this distance. So this is what Euclidean distance, okay? The straight distance. On the other hand, the Manhattan distance, in this one, the distance in between A and B and C is considered. So why this is the difference? This is the difference of your based on, I mean, your need or your work. Suppose if the work is where the straight distance is there, my means from A to B, there is a flight from Kochi to Bangalore, then this is what Euclidean distance. But if you are doing some work related to the urban planning, then it is the road which you have to think like this, that okay, this is the distance here and this is the distance. So in that case, you will choose Manhattan distance. So if you are taking the Euclidean distance, in most of the cases, the Euclidean distance is taken. So let's begin with the okay. Let's see. So the calculation here: average nearest neighbor. Okay, average nearest neighbor. Look at this. Average nearest neighbor. Suppose this is one area. In this area, you have taken the points of your interest. Sorry. So in these points, suppose there are 100 points. So you see the distance in between these two here, it will be considered. The question is, why not distance from this point to this point? Because here the nearest word you have to look at. So all the distances, for this the nearest may be this one, for this the nearest may be this one, for this nearest may be this one, for this the nearest may be this one. So all the observed distances, okay, the average of all the distances divided by the expected distances. So here this is for observe all the distances divided by the number of points. So that will be observed distance. The expected mean distance will be, the formula is here 0.5 divided by under root like this. So A is what? A is the area and these are the number of points. So in the software, if you know the area of your study, then you can give the area. Otherwise, uh, software will make or will calculate the area like this. So with the help of software, we will see like this. Okay. So the result is that if the the result is if it is less than 1, then it will be clustered pattern. If it is here, I mean nearest neighbor index is more than 1, then it is dispersed. Or if it is near 1, then it is randomness. We will see it. Okay, with the help of software, we will see it. Here I will go for software demonstration. So this is the software which I was talking about, that is the ArcGIS software. And I mean a lot of videos are there that what is ArcGIS and what is the, you know, the tools and everything, what is the interface of the software. So what I have done is here in the software I'm using the data which is related to Kerala here. So let's see here, Kerala, and these are the village boundaries, and these are the districts, Kerala districts. Let me take the all the districts here, you know, the all the districts where I can take all the districts here. These are the districts, states only. Then yeah, these are the districts here. So for pattern analysis, I have taken some points in the Malappuram district, and these are the points. Yes. So okay, these are the states, and here let's see the outline, and here this is the Malappuram district, and in this district we can we can see the points, villages. All these are the villages. Here I'm doing nothing, just I want to know that what is the distribution pattern of these villages. What is the distribution pattern? So for that very purpose, what I will do, this is our toolbox. Okay, our toolbox give you the tool sets, and within these all tool sets you will find, okay, these are the toolboxes, then these are the tool sets, and under the tool sets you will find the tools. Do not get scared, my dear participants. Why? Because sometimes it seems that it is very complicated. No, it's very very easy. Once you will practice maybe 1 or 2 times, you can do wonder in geostatistics. So the analysis you will find under the spatial statistics tools. Let's see. Then analyzing the pattern. Then here is the average nearest neighbor tool. And the good thing is that if you wanna know that what tool is this, you can click at this tool help. So the tool help will take you to the help part. And with the help of this help part, you can study that how this tool is working, and how this tool works. Like I was explaining you that what is the calculation here. So all this is the calculation given here, which you can read for your references or for your understanding. What I will do is just I will give the my input feature class. Then you want to generate report? Yes, I want. Okay, I want, yes. And here is the distance which I was talking, Euclidean distance and Manhattan. The Euclidean distance is a straight line distance between 2 points. It's a crow, crow flies, okay? Yes, crow flies, A to C, something like that. On the other hand, Manhattan, the distance between 2 points measuring along axis at right angles, okay, like city blocks, okay. The third is, if you know the area of Mallapuram district, you give the area, otherwise no problem. Software will take the area with the help of these connecting or the points. Okay. I have given the option generate the report. Okay. Here my report will be there. So do it okay. Do it okay. So your work is completed. Then you need to know that where is the report. Your report will be there in geoprocessing, then the results, and here this is my session, current session, and here this is the report file. When you will double click, you will find the report that the pattern is what? The pattern is dispersed. The pattern is dispersed. What software did? Software calculated the observed mean distance. It is around 3.8 kilometer. This is given in meter here. Expected mean distance is 2.9 kilometer. Okay. So this is what? This is the ratio. Observed divided by expected. So the ratio is 1.3. So as I have already discussed, if it is more than 1, then the pattern is dispersed. So this is what? It is dispersed. Then in research, okay, by visualization you can understand, okay, this pattern is dispersed. But as a research, you have to write that uh, it calculated the z-score, and z-score is 7.0, and 7.0 of z-score you can see here, the z-score here. So z-score, if it is about 2.58, means you are more than 99% sure that the pattern is what? The pattern is uh, dispersed. So p-value is also very, very less. So I mean, you can, you see that given the z-score of 7.023, it shows that there is less than 1% likelihood that this dispersed pattern could be the result of random chance. Okay, so what is your, you can frame your null hypothesis that the pattern is what, randomly distributed. Okay, but you can reject this null hypothesis and you can say no, there is 1% likelihood that it may be due to random, but you are sure more than 99% that this pattern is what, this pattern is dispersed pattern. So what you can do is you can take all these values to your results and discussion part, where you can give that, okay, mean observed distance was found this much, okay, in between two villages of Malapuram district. But as far as the distance should be even less than that. So this is the ratio. This is the nearest neighbor ratio, and z score is this. As you remember in that formula, the z score, how to calculate it was also given. You can back and you can pause the video and you can see that one. So your first objective of your research will be completed very well, and you can say, okay, this is the pattern. Fine. I will. And now the second one is the hotspot analysis. So in the previous one, when I was talking about the pattern analysis, then in pattern analysis, there was no generated map. It was a report only that, okay, this is the pattern. It is clustered or dispersed or random. And it has given to you the statement to reject or accept your null hypothesis. Now here we will talk about the hotspot analysis, and in this analysis, when you will do this analysis, there will be a map of hotspots. Okay, these are the hotspots of the problem and these are the cold spots of the problem, and this is the area which is statistically insignificant. So maybe your interest may be in the area which is hot spot, higher values, cold spot means lower values. So when you will see this topic, hotspot analysis, again you will find around yeah, 1 lakh, more than 1 lakhs results. And the hotspot analysis here, he's doing it for forest fire risk. Here, hotspot is doing to detect the cluster analysis. He's doing hotspot analysis for forest fire. Okay, let me say one thing. Sometimes, you might be thinking that if you are from social studies or from another discipline, then you might be thinking, what is the need to study the forest fire? Okay, especially for social science and maybe science students, I will highly advise you to study this thing. Why? Because nowadays the data is available. If you will go to the uh, data providing interfaces or websites, you will find a lot of data is available, and that data is freely available. You simply go and collect the data and you take this data into your software and you just analyze and just start publishing your paper. So you can go to the field and you can collect the GPS data also, and that GPS data also you can use for hotspot analysis. And if you will see the COVID data, this COVID-19 was a favorite topic of the research journals, and many research journals, they were publishing work on COVID-19 at very fast track. And as far as data is concerned, the data was available. Uh, the data was being given by the government agencies. And okay, I mean, this is the data which you can use, and that is the another part, whether how much correct is the data was or how much not correct. That accuracy, validation, the results validation also, it is possible. That how it is possible that this is the area where as much high value and the area which is very close to this lower values. So you can do the data validation also. So the data validation will make you enable and more confident to say something related to your problem which you are studying. So let's begin the hotspot analysis. Hotspot analysis. Okay, as you can see here, the figure is given. This was, I mean, maybe the input here, the any data like maybe population density data is given. Then what it will do, the important thing is here, this is the z score. Okay, z score. So the z score, if you will say, okay, I can take in the Excel, I can take in the Excel, and there also I can calculate the z score. But as I have already told you that geostatistics include the spatial information, spatial information. And very important point to understand here is the hot spot analysis. Spot, okay, the higher values, where the higher values are clustered. So this is the hot spot, hot spot. You see, this point is also giving you the high value indication, but this is not in the hotspot area. This is statistically insignificant, not significant statistically. Why? Because this is not making a hot spot area. Why it made a large hotspot here? Because the higher value, if surrounded by higher values, because the closeness effect will be given to the higher values. Okay, if the higher value surrounded by higher value, then it will be a hot spot. If a higher value is not surrounded by higher values, then it will not consider it as a hot spot. Why? Because the value of each polygon will be influenced by the surrounding values, so this is the reason, try to understand that in the middle at this polygon here, the light values are given. I mean, the light color shows the lower values. Still, it is considering as a hot spot. Why? Because this low value polygon has taken the weightage of surrounding high values. So the surrounding high values has influenced or changed this value, and that is why this whole spot is being considered as the hot spot here. So again, when you will do hotspot analysis with ArcGIS software, then you can go to the tool and tool help, and you can read a lot of things related to hotspot. How does it work? What are the results? And when the results are there, what are how it works and how you can interpret the results, and what are the merits and demerits also. Okay, that also you can study or you can read with the help of the tool help if you are using that software. Okay, let's see what are the steps. The steps are, first you should prepare your data. Okay, I mean, your interest may be the crime rates, maybe population density, maybe disease incidence, or it may be related to any information, maybe the number of the mobiles users, then the per capita income, may be related to the anything, I mean, which you are studying on the surface of the earth. So uh, so at district level you can collect much more information than in ArcGIS. Let me explain you here. Okay, suppose here these are the columns. These are the columns here. These are the columns. In one column, there will be one ID. Here, suppose this is district. This is the district, and here this is population. This and this is ID 1, 2, 3. District maybe like district A, district B, and district C. There may be 50 districts, 100 districts, 500 districts. So on the other hand, you have a huge Excel data, and in that data, all socioeconomic information is given, containing many columns, and in that one, there will be the name of the districts here. Then if the districts name are the same, exactly the same of these districts names, if there is some variation, you can make the same names, or you can take the ID, the same ID here, and you can make the same ID here. Then you can take this Excel sheet to the ArcGIS software and you can join it. Your data will be joined. Okay. Then all the information will be in your ArcGIS software because you have already joined based on the similar field. Similar field. So you have a lot of options, opportunities. You can take the data from different sources, from RBI, from Niti Aayog, or from statistical departments at state level, at country level, at international level, belonging from different organizations. So you can take that data and you can use ArcGIS software to do geostatistics. So this is what the data preparation. Okay, and now this is the setting of neighborhood distance. Okay, neighborhood distance here. How you will set? When I will go for some software demonstration, then I will show you this thing. Then it is what it is doing. It is calculating the local z-score. This is not simple z-score, but it is local z-score. Okay, and local z-score means that if these are the polygons here and these polygons have different values, like maybe this is 5 here and this is maybe 50, this is 50, then after giving the weight, these values will be changed here, because here you are giving the neighborhood distance. So the nearer feature will give the influence to this one, and this 5 may change to the maybe 25, maybe 20. So this is, you can think like a demerit, because the original values are changing, but the merit is you are getting a hot spot. So a hot spot will be the point of interest or the region of interest, maybe for the researchers, planners, and the top management, like that. Then this is all being done by the software. Okay, aggregating z-score, it is also done by the software. It aggregates the z-score, and now you see, I can explain you here better. So this is the name, which is pronounced as Gettys ORD, Gettys ORD GI star here. This is known GI star. Okay, so GI star nothing but a local Z score. Okay, here you can see that this is the division here. This is the division. What is W? W is the weight. What is I and J? There are many points. Sorry, there are many points. Okay, if your work is based on polygons here, then there may be different polygons. Okay, and each polygon will have a value. Here each polygon may have a value like this. So what is ij? This is 1, that is I and j. Ij. Similarly, maybe ij, ij, ij. This is the width. This is the width in between what? Two features I and j. Spatial weight between feature I and feature j. So all this spatial weight, and times the local value will come, the z, the here this is what the local z score of the feature j. Okay, then what is this? This is the sum. This is the sum of all these values. Okay, so remember, okay, the hotspot value belongs to 1 point. So based on that GI star, based on that polygon will be decided whether it is a part of hot spot or cold spot or statistically insignificant. So this value will belong to each polygon differently. So when I will do some, you know, when I will do some software in the software demonstration, then it will be more clear to you. Okay, the interpretation. Okay, positive high values are the hot spot. Negative low GI star values indicate the cold spots. And in between some, you know, the part which is lie here in the distribution, it will be statistically insignificant. And this will be, you can say, cold spot, and this will be this area will be the hot spot here, maybe like this. So this area will be the hot spot here. So let's see the
So
software
now again
demonstration.
I'm here with my software, that is ArcMap, and the data you are familiar with. This is Kerala at district level. And in the last demonstration, what I did is I uh, studied that what is the pattern here, and we found that pattern is the dispersed pattern. And now let's see some another information here. Like, okay, these are the polygons given. Okay, these are the polygons given, and this district belongs. This district is Malappuram district, and inside, because these are the villages here, and these empty areas may be the urban areas here. So let me show you the data. I mean, this data I think is the data, socioeconomic data, and it belongs to 1991. So it is very old data, that this is the village and these are the village names, and these are the village names here, and each village here number of household, the total population, total male, total female, and much more information is given here. If you want to know, if you want to download this data, you can download. It is available on, uh, I mean, there is a socio-economic data given by the NASA. So in their interface, this data is available not only for Kerala, not only for Malappuram district, for all the districts of India, not only for Kerala, at village level. And if the data is for 1991 or 2001, because 2001 is also there, I know, and this data may also be for 2001, I'm not sure, maybe 2001. So based on the growth rate, you can go for the for 2011 and 2021. You can make some kind of, the analysis here. And okay, so this is the data I have. And if you need this data, I can share with you this data too. Okay, so what I want is, I want the mapping the clusters here. So this is what mapping the clusters. And here you can use another tools also. Here I'm using the hotspot analysis, this get SWOT GI star. Okay, and you can, as I have already told you, as you open, it may be like this, but you can click at show help and you can click at tool help. You will find a lot of things given. You can study, and if you want to learn more about how this tool works, you can click at this, and there is a formula given here. And that formula which I explained you was the easy version of this only here. So this is the only formula, and this is further explanation. But because GI star is a statistic, it's a z-score. Okay, so no further calculations are required here. So this is the z-score. Okay, so let's see. And for that I need a value. Okay, earlier I just calculated the pattern, the spatial pattern of uh, I mean the from the viewpoint of the distance where the things are located. Now this is the Kerala district. I mean the name is Malappuram here. What I want to know is, if I take the total population here, the total population, then what are the hotspot? Now here is the point coming. Okay, the point is conceptualization of spatial relationship. This is the fixed distance band. This is by default itself, no need to give. But if you want to know more about that, how does it work, then you can read the inverse distance. Inverse distance is that nearby neighboring features have the larger influence. I mean, if I say this village, and because the value will be changed based on the neighboring values. So how? Maybe higher influence will be of the nearer villages, maybe 50% or 70% influence. So inverse distance means as the distance will increase, the influence will decrease. And inverse distance squared means that that influence will be more only. The slope will be sharper. Okay. For this polygon, maybe 90% influence. For this polygon, maybe 10%. Then no influence of this one. Then fixed distance band means it will give you a distance, okay, within 50 kilometer or within 100 kilometer of area from the point of this polygon, you give the influence, and rest villages values do not give the influence to this one. Okay. Then similarly, there are some another like zone of indifference, where what happens, features within the specified critical distance. Okay, so as you will move away from that distance, the weightage will change. Here in the fixed distance, weight is only one for all that distance. Suppose there are seven, uh, but if the critical threshold value, thresh value distance, as it will move away from that point, the weight will decrease. The weight will decrease with the distance. Age only. Suppose this is the polygon here. So whatever the polygons, whatever the villages which are touching this edge will be included. I mean, for this polygon, the influence will be of touching the edge here. And because this polygon, this village is not touching the edge, so its influence will not come to this polygon. Okay. Similarly, the edge corners here, in place of edge, it takes the corners. Okay, the corners here, this one, this corner maybe. So another is the spatial weight is calculated by the software. So this is some another, how you can calculate the spatial weight as per some, giving some more insight. So that is, if you will see maybe, okay, if you will see maybe in the utilities, how you can calculate the spatial weight after taking the calculator. So you can calculate and you can give here. So uh, hotspot analysis. Input feature. What I want to give the villages of Malappuram district, and my interest is I want to take the total population. You can take any variable. Okay, here I'm taking the total population, and here I have given the fixed distance band. Okay, then this fixed distance band is given by the software only. The Euclidean distance we have already discussed. Okay, in this case, Euclidean distance by default we can um, keep as it is. Then let's see. You can give any location of your results, but here by default is this location. Okay, no problem. And now let's do it. So you got this one. These are the results, and if uh, you want, you can make. I mean, you can make. You can take it into the layout here, and you can zoom in to of your interest. Then you can give some many more things like insert the title, the north arrow here, and you can give the scale bar here. For instance, if I am interested to give the scale here and kilometer, apply it. Okay, then I can give the scale here. Why? Because I'm explaining a scale. Without a scale, a map is not a map, it is a sketch. Okay, so you can give a scale, and you can give a good arrow you like here. Okay, and you can give a heading here. You can give here. I have taken the text here. Okay, so you can give the hotspot whatever you want to give the name, hotspots here. And okay, hotspots here. You can right click property and you can choose the size here, hotspots. And by the way, from here also you can choose some tools like if you need to make some draw work, then you can choose and you can buy 26 here. Then you can, and you can make hotspots of maybe Malappuram district.
like this. So I'm writing in short here, or I should make it uh, Malappuram district hotspots. And you can write like this is the population of 2001 or whatever data is there. Thereafter, these are the legends. Okay, these are very important legends which you can give these legends here. Then these are the legends which are Kerala district hotspot. These are Kerala district no need. Then you can make it next, next, and next here, next. Finish it. So these are the legends. And here you, if you want, you can make the name of the villages, name of the villages. Here you can make the labels and the name of what the name, yeah, maybe this one, name of the villages. Yeah, these are the villages name here. So you see, these are the villages, these are the villages, these are the villages, these are the villages where the population is low. That's why this is cold spot here. And maybe here, maybe some mountain range, maybe there, and this is maybe a pass, and on the other hand it is a plain area. Again, this is a plain area, this is a plain area, fertile area, where the population is more. On the other hand, in some of the villages population may be more, but it is insignificant. Why? Because it has taken the values of surrounding lower population. That is why. So this is the way you can. And now let's see the results you can analyze here. So what is this? The total population is given here. So this is what, this is GIZ score. Okay, this is the p values here. This is the bin here. Bin is here. Okay, so where on the map you will find these bins. So these are the areas, these are the areas where the GIZ score, Z score is in negative, is in negative, 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 negative. Okay, and these negative values are showing that the area is lying in the cold spot. On the other hand, the higher values are showing the population is more and surrounded by the more population villages. I'm telling you again, maybe any village here may have higher population, but due to the influence of surrounding villages population, so the population has been changed due to the influence of neighboring village. Here the objective is that you have to find a hot spot here. This is not exactly the, because the values are changing, so it's a demerit that it is not showing any, I mean any district which is having higher values. If you are interested, the villages like that which are higher value and surrounded with lower values, then for that I will suggest you to use this tool here, cluster and outlier analysis here, this one. By the way, this is not given in the presentation part, but for your better understanding, I mean, if you are interested, then you can use that one. Here, let's take the same, the total population here. We have already discussed the conceptualization of a spatial relationship and distance method. And now let's see that what will be the results here. So in this one, you can see that the higher values are surrounded with lower values here.
These are the districts which are surrounded with lower, means isolated higher value, isolated higher, surrounded with lower value. Then lower value surrounded with higher values. This is the blue. These villages have low population but surrounded by higher population. And these are the higher and higher clusters. Higher and higher clusters. So this is the way you can go for cluster and outlier analysis also. But before you use, I will highly recommend you that you please go to the tool help and you see and you read all these things, that what are the merits, demerits, result interpretation, your data and all. So this was about the hotspots analysis, and I have included this also just to explain you if there is a need of that kind of objective. So the second objective, you can say that to map the hotspots of your problem. First pattern, then second the hotspot. And in the next part, we will talk about the modeling spatial relationships.
So this is the modeling spatial relationship, and the as you can see here the relationship. Okay, so it means we are talking about more than one variable. So far, what we are talking, we were using only one variable here. But now the spatial relationship you can model in between two variable or more than two variables here. Two variables may be like the rainfall or maybe the temperature, and the second may be the cold drink sale. As temperature is increasing, what is the impact? The coke sale is decreasing, something like that, for an example here. So what is the I mean, you can take more than one variable. So how it will help you? I mean, it will help you to understand the causes of the changes on the surface of the earth in different villages or something like that. Maybe at district level or maybe at state level, something. So when I uh, searched this topic, modeling a spatial relationship in Google Scholar, again there are 9 lakhs 33,000 results. So why I'm showing you this one, because you can understand that this topic is also very important topic. Modeling spatial relations of what they are studying here, and in very quality journals this all this work is being published here. Healthcare planning, uh, this modeling, because and this is a book here, and you can go on and whatever the paper you can read and you can have more idea about the modeling spatial relationship. And in my channel also, in my YouTube channel, I have explained this topic in a very descriptive manner. And if you are interested to study or to if you want to know more about this topic, you can uh, open my YouTube channel and you can see 4 5 videos are related to modeling spatial relationship only. And then again, if you will see the modeling spatial relationship, you will find in the software there are two methods given. One is OLS, that is known as ordinary least square method, and another is geographical weighted regression. Okay, here what I'm using is OLS, ordinary least square regression in GIS. Okay, in this one, what happened? There is a dependent variable, Okay, and there may be one or more independent variable, more independent. Suppose I was talking about the dependent variable is the coke sale, and you have to explain with the help of independent variable, maybe the temperature, maybe per capita income, maybe the distance from the city, like that. There may be different variables which you can use to explain the variability in the coke sale based on the variability in the independent variables. So what is this? How you will do this? Okay, first of all, you should have the data in the form of data. I mean, you should have the variables. Suppose here this is what? This is the district here or village name. Here may be variable 1. Here any variable, maybe a variable 2, then 3, and it's easy to give in the software. Okay, when I will do it, it will be more clear to you. Then this is the model specification, and I think most of you will be familiar with this equation when you do the spatial relationships. Y is here is the dependent variable, which it will be predictive. It will be predictive. Suppose here this is y is the value which will be predictive. Okay, predict based on the coefficients, based on the coefficients here. And this is what? This is independent variables. Maybe x1, maybe x2, and maybe different here. So the interpretation of the results will be there with the help of software. And what software do is there is a residual analysis. Okay, so one is observed. Observed is suppose coke sale is maybe 50 or maybe 5,000 in a day. Okay, and this is the temperature here, per capita income. So what it will do, it will take all the values in a district. Okay, so based on all the values, it will give you here, as a result the predicted predictive value. It was predicted that it should be 6,000 based on the another villages information. So here, what is this? The residual is minus 1k, minus 1,000. So minus 1,000 means the coke sale is less here than predicted. How much less? So based on this predicted values, the mapping will be done, and that mapping will help you a lot to understand the spatial variability. I mean, with some information, with some diagnostic, you can validate that whether you should accept this model or not. So this is related to the spatial relationship, and now we'll go for software demonstration. So again, I'm here with my software, and this was the tool which I took. This is the layout tool here, uh, and this is the last exercise I was doing. And one thing was remaining is, if you want, you can export this map, and this map you can export to your location, and then you can import it as an image to your work. So this was about the hotspot analysis, and now this is because this is the data view.
You see here, this is the data view, okay, layout view, okay. Sorry, this is the layout view here, and this is the data view, okay. And let me, okay, here. And now you see the attributes are here. So let's choose the attribute, the number of household, total population, male population, and female population. Okay, so just take two variables here. I'm taking here two variables to understand this relationship. And because here you see the male population is 9796. Okay, this is this village here. So with the help of these two variables, male population and female population. Male population I will take as dependent variable, which I want to know in relation with females, males are less or more. I mean, considering the another villages. So what I will do for that is I will go for modeling spatial relations, and I will go for ordinary least square here, OLS. And in this one, I will give the Kerala districts features here. You have to give a unique ID, and that unique ID should be, the numerical, should have numerical, means I'm giving here the ID, okay, and output feature where you want to save your results, then you can choose. I'm keeping it as it is. What is your dependent variable here? My dependent variable is male population. And explanatory variable, which is independent variable, I can say that my independent variable will be the the male. Now this is total female population. Okay, okay. And there is a report file which is very important. I mean, for your diagnostic or for your validation of the result, and you can how much sure you are that your work is, I mean, is acceptable or not, because variability in the dependent variable is being explained by the explanatory variable. So if it is not that variability is not being explained by the explanatory variable, then if it is not, so means the model, you cannot trust that model. Okay, there is a problem. So that way, what you will do, you have to give a location that where you want your report. So let me give it to some place here. Okay, let's see, here I want the AST as my report. Then let's choose this one, AST PDF. Okay, now let's do it. So here this is our result, and in this result you can see that the lower values here, the lower values, these are the standard residual of what you see it here. These are the standard residual, the residuals which are standardized here. Let me see here. The lowest one is minus 2.68. Why this is like this? Because here the total male population is 41655, but estimated is 42988. So total male population minus estimated population. So this is the difference here. This is the difference. So male population is very less compared to estimated. That is why here here in compare, I mean, because all the values are involved in this analysis. Okay, in this very village, the influence of all the values. That is why uh, the compared to another districts here, you can see here up to maybe 1.5 something like this. Okay, uh, these are the villages where the population is male population is very less. On the other hand, these are the villages where male population is more than, not exactly more than females, but compared to another villages. Okay, compared to another villages. And this yellow part is the villages where the population is statistically insignificant. I mean, the difference is insignificant. So we'll talk the I mean, you can take the data from here also of in the results part. What you did is ordinary least square, and these are the messages here, and you can have an information of you see this is the r square value, that is 0.993. What does it mean? It means that variability in the male population is being explained by the female population. How much? 99.93% variability in the male population is being explained by the female population. This is something, the data I have taken, it is like this. It may be zero point 0.8 also. If you are doing analysis with another data, it may be 0.75 also. It may be 0.50 also. Because, if it is 0.60, I mean, if it is 60% variability explained by the explanatory variable, then it is also a kind of information which you are getting in your data, in your information. And there are another diagnostic results which you can see and you can read, and where your model is good model or where your model is weak. So such type of information, this is the data here. I mean, this is the PDF file, and we can see this PDF file. Okay, so this was about the spatial modeling spatial relationship with ordinary least squares. Then again, you can make such type of things like the layout view, and then after doing all these corrections, you can export your results and you can use in your research work like this.
And now let's discuss the recent trends in geostatistical analysis. As we know that there are some recent trends which are coming like big data and high resolution imagery. So when the resolution of the images will be high, uh, so the accuracy of your results will be more. There will be more detailed and accurate spatial analysis. There we are geospatial artificial intelligence and machine learning. This also is being used in geospatial studies for improved prediction, classification, and pattern recognition. And location-based services have been improved too much. Why? Because there is, in the mobile devices also, there is more real-time locations available, so we can use such type of data, and which can give us more insight in geostatistical analysis. There is 3D and virtual reality. With advancement in 3D modeling and visualization, we can go for very good analysis, spatial analysis, especially in urban planning and architecture. Spatial temporal analysis, there is space as well as time, and as time is passing, both these such type of studies for studying the change especially is increasing day by day. There are open sources and tools, many more, like QGIS. I was talking about ArcGIS because I'm used to of this software. But if you want some open platform, then you can use the QGIS also. Is very useful and widely used software, that is QGIS. You can go for web mapping also and GIS cloud services. So in the web mapping, you should have the server's name, then you can use these servers to import or add your data, and then you can use analysis. There is some kind of spatial data privacy and ethics also. As time is passing, is also coming more and more that uh, to, I mean, this is to balance the benefit of spatial analysis. Then natural disaster and management is easy now to predict the hurricanes, wildfires, and floods well before the occurrence these events. Why? Because a lot of data related to the weather, especially weather information models, are there, which are being giving us more information about the early warning. As you can see here, the in Arabian Sea, around 1 month before, or more than that, 40-45 days before, there was a uh, I mean, very huge cyclone, but the casualties were very less. Why? It was everybody was prepared for that. That's why. Then there are the smart cities, urban analytics also. So these are the recent trends, and there may be another recent things also which is not covered here. And maybe because as time is passing, the technology is changing very, very fast. And now let me talk about this Google Earth Engine. Okay, Google Earth Engine is a very good platform to collect the data, to analyze the data, and to present your data. And this Google Earth Engine helps you because what Google has done, there were many programs, uh, active programs since 1972. I mean the satellite programs. So the Google has taken or bought or something acquired the images from the satellite. For example, the Landsat program. The Landsat program is the program of USA, and this program is running since 1972. So right from 1972 until now, and another also, I mean in future also, whatever the images are there is being collected by the Google, and they have made a Google Earth Engine. So with the help of this Google Earth Engine, you can interact with that data archive, with that massive data archive. And in that, different types of like Landsat, Sentinel, and Modis data is available. And that you can go for geospatial analysis, you can go for time series analysis, you can use the custom scripting, you can go for interactive visualization, and you can go for global scale analysis also at any level. And this is very important for educational and research use. You can go for collaborative work, and for that what you have to do is you have to use the Earth Engine code editor. So just let me show you something related to Earth Engine code editor. So here, as you can see here, when you will take this code earthengine.google.com. Okay, so first you need to go for registration. Once you are registered with the Google Earth Engine, then they will give you the rights to use this code editor. And in this Google Earth Engine, you can see my videos which are on Google Earth Engine. There are 5-6 videos which will be helpful for you to handle with this interface. So Google Earth Engine is something which, if you want any data, Landsat data, then you can see that what are the data available, or you, if you want to go to some places like maybe okay, I mean in this platform, I mean in this interface, this is also very important to see the help here. Okay, user guide is there, you can use that one, and this is the part you can use your script, which is based on Python and JavaScript. And here will these are your scripts, here some are the documents given, and these are the assets which you are having in the form of your spatial data. So let me see some uh, with the help of some uh, small analysis, that is buffer analysis. Here, this is the buffer analysis, and what I tried to do is here in this one, in the buffer analysis, I gave the distance of 5,000 meter around my point. Okay, and my point is here, my point is here, this is my point, because internet is not so fast. Okay, here this is my point of interest, and I ask with the help of this small script, which you can also use. I mean, just you write the same script here, and you can put on your this scripting part, and then you can do the run. As you will click the run, it will give you whatever points you have. It will give you the buffer of 5,000 meter. Okay, this is buffer of 5,000 meter, and this 5,000 meter, I mean, is I think both sides, left and right. Here the scale also you can see here, this is the scale here. And if you are making the another points, whatever points you want, and you can go the run, then it will give you the buffer of these points also. The not only the single buffer, if you are interested in multiple buffer also, you can go for multiple buffer also. Then you can, but one demerit is it's highly dependent on your internet speed, I'm sure, because this is the place where I am, internet is not so fast. That's why it's taking the time. So multiple buffer, if I click this one, then it can give you the multiple buffers. So this scripting, you can get a link here, and just you can share this link to anyone, and if anyone will use the same link, I mean can use a single link, and then he can go for some kind of changes, or he can use your scripting for the work. Like, yeah, here these are the multiple buffers. And what I said is, I said start with uh, 1 kilometer, and with 20 kilometer, and each buffer give me of 2 kilometer. So this is done by the Google Earth engine, and which is very useful for geospatial analysis and geostatistical analysis. So I think it's enough for now, and I say thank you for the organizers as well as the participants. A special thanks to Dr. Munir, my friend, to invite me for this lecture, and Thank you so much.